In our last section of this unit, we're going to be taking a look at applications of exponential and logarithmic models. So if you take a look at our first example, we're given an equation for cell phone subscribers based on years after 2000. That's our t variable. What we're given is the number of subscribers, and we need to determine how long that takes. So notice we're solving for t. So we're going to start by substituting not 90 million. The other thing we need to notice on this one is that our number of subscribers is given to us in thousands. So we have to figure out how many thousands 90 million is. The way you do that is you just take 90 million and divide it by 1,000 and you will get 90,000. So we are going to substitute 90,000 for C, the number of subscribers, and we will solve for T. So notice the variable is in the exponent. So in order to get the variable out of the exponents, we will have to use logs to solve this. So we're going to start by dividing both sides by 55/35. I would recommend not using your calculator for a decimal approximation until you absolutely have to. In this case, you can go ahead and write down that fraction. The reason I recommend that is because you end up with less rounding error by the time you're done if you round at the end instead of several times along the way. Next, to get the variable out of the exponent, we're going to take a log of both sides. You can choose a log of any base. You could do the curly law to undo this if you wanted to. I am going to use a log that my calculator knows, so I'm either going to choose the common log base 10 or the natural log base e. Both of them will work. Both of them give you the exact same result, so you can choose which one you want to use. Because I'm guessing more of you are comfortable with the common log, I'm going to go ahead and use the natural log. So I'm going to take the natural log of both sides. And once I take the natural log of the right-hand side, I have a power on what I'm taking the log of. So I can use my power rule and pull that t down as a coefficient. So I'm going to do that next. And then my final step will be dividing by natural log of 1.413. And then I can get a decimal approximation for my t. I got about 8.067. And then to answer the question, t is time after 2000. So of course 2000 plus about 8. It took until 2008 for the number of subscribers